Greeting of the day, I am Rajkumar Parashari and I love doing physics. Today I am here with the topic power of accommodation of a hypermetropic eye. The power of accommodation of a hypermetropic eye has to be less than power of accommodation of a normal eye. The eye of a person who is suffering from hypermetropia can focus all the objects lying at far off places at the retina. However, if the objects they lie close to him, then the same eye is unable to focus that on the retina. In fact, in this case, rays focus beyond the retina. This is because ciliary muscles are unable to constrict accordingly and enable eye lens to focus rays at the retina. Observations suggest the person is able to focus all the objects lying between infinity and near point. It means his range of vision now has reduced from infinity to near point. The eye is able to accommodate all the objects that lie between infinity and near point at the retina. And the object, if they happen to be between the near point and the near point, the eye lens is not able to focus them at the retina. And that is why person will not be able to see any object that lie between the near point and the near point. Let's try to find out the power of accommodation for a person who is suffering from hypermetropia. See, the person is able to see the objects that lies at infinity. It means that for object being at infinity, u is equals to minus infinity, v is equals to plus 2.5 centimeter. Let's try to find out the focal length of eye lens in this case. We can do it by using the lens formula. This implies that the focal length is equals to plus 2.5 centimeter and the power of accommodation. The power of accommodation can be calculated using the formula 100 by f diopter, and this is equals to plus 40 diopter. When the object lie at infinity, then the power of the lens, the eye lens, is equals to 40 diopter. Let us calculate power of the eye lens when the object lies at the near point. I am assuming the near point to be at 80 centimeter. I should also be sharing this point that for a person who is suffering from hypermetropia, the near point shifts little away, and I am calling that as the near point. And when the object is considered at the near point, then when object is considered at near point, in this case u equals to minus 80 centimeters, v is equals to plus 2.5 centimeter. Let us assume f dash to be focal length in the new context. It can be calculated using lens formula. 1 by f dash is equals to 1 by v minus 1 by u. If you want to write v dash and u dash, you're welcome. Substitute these values. This is 1 by plus 2.5 and this is minus 80. Take 200 as LCM. Now as you take 200 as LCM, so what should you be getting is 80 plus 2.5, and this implies that the focal length in this context is 200 divided by 82.5. Now the power of the eye lens in this case, P is equals to 100 by f dash diopter, and this is equals to the new power 100 divided by 200 upon 82.5, and this you will get as 41 plus 41.25 diopter. Now you see, when the object lies at infinity, then the power of eye lens is 40 diopter, and when the object is brought closer to the new near point, then the power of eye lens becomes 41.25 diopter. It means the power of accommodation of the eye lens now has reduced from 4 diopter to 1.25 diopter. So power of accommodation, the case I have considered should be plus 1.25 diopter. Is that right? And if the new near point is different, if I take 160 centimeter, 100 centimeter, automatically power of accommodation will be different. All that has to take how much constriction these ciliary muscles can do once the person becomes hypermetropic. Thank you so very much for being with me throughout the content. God bless you.